Innovation and Design Thinking. IDT. VTU. Module 3. Design Thinking in IT. Case Study. Bringing Design Thinking to Business Process Modeling. By J. Babu. Bringing Design Thinking to Business Process Modeling. This is a research work carried out by Alexander Lube and Matthias Wesk, Hasso-Plattner Institute, University of Potsdam, Germany. Business process management is at the heart of organizations. It provides concepts and methods to capture, analyze, and improve operational procedures in the daily business of organizations. The elicitation of process models is the first step in any process improvement project. Process models mediate communication between the different stakeholders involved, such as, for instance, business analysts, process participants, and software architects. Process models provide a shared understanding so that everyone can contribute knowledge. Based on design thinking principles, authors developed a method that aims at improving business process modeling. To achieve this goal, they introduced physical building blocks and methodological guidance to fundamentally change the way people interact with process models. Tangible prototypes have been successfully used in design thinking, and initial experiments show that a tangible toolset is a promising approach to improve business process modeling and comprehension. Business process management evolved as an organizational approach to structure and better understand work in organizations. The idea is to investigate procedures that drive the daily business operations of companies with the goal of improving them. As an example, a key process in an insurance company is the processing of insurance claims. Saving an average 5 minutes in the processing time of a single claim ends up saving considerable resources, given the high number of cases that an insurance company deals with. From a business process management perspective, one can identify people that are involved, information that needs to be gathered, tasks that have to be performed, and decisions that have to be taken to get a claim processed. Analyzing the process can reveal flaws or point to improvement potential. Eliciting information and making process knowledge explicit is the role of business process modeling. The models are captured as visual diagrams as shown in figure. See the figure. Figure shows a sample process model depicting a simple view on claim processing. It shows process participants, clerk and expert witness, and events like new claim arrived and claim processed, and activities like assess claim and a decision like obvious case, and a document like expert report. Process models map out roles, tasks, decisions, and information used. The visual elements have a distinct semantics, which allows to represent complex processes in a compact way. That makes process modeling a powerful tool to share knowledge. Process models are the basis for discussions between the stakeholders involved, such as process participants that process claims in an insurance company, managers that have to ensure claim processing quality, the top management that is looking for optimization, and software architects that shall support the work of the employees by providing adequate software systems. Process models mediate communication. Business process management, BPM, emerged as a discipline that provides a broader perspective by addressing organizational aspects as well as technological aspects. It addresses the full business process management cycle, from analysis to redesign to implementation to operations. Process models are essential artifacts in all of these phases. To visualize the implicit knowledge, process models are created. These are compact drawings that capture the activities to be done, their order as shown in figure earlier. This idea can be traced back to flowcharting techniques in the 1970s, and it evolved over time. In particular, the IT had an interest in a compact and precise description of the process, which usually serves as a requirement documentation for software implementation. To support the full cycle with software tools, formal means and unambiguous process modeling were required. As a benefit, formal models can be used to configure software systems and shorten the time needed for implementation. Specialists, usually process analysts, conduct individual interviews with stakeholders or hold workshops to elicit the process-related information. Authors studied process elicitation and observed the path that a process model takes from the conversations with domain experts to the implementation at IT departments. The workshops usually use whiteboards, flip charts and post-its to capture process-related knowledge. The quality of the extracted information relies heavily on the experience and skills of the process analyst. He must listen carefully, read between the lines, and extract the knowledge relevant to the process. The process analyst creates a process model, an abstraction and reframing of all notes and impressions that he has collected throughout the workshop. The process model now becomes the central artifact that reflects the findings from the workshop and is used in all subsequent discussions and negotiations. The stakeholders are asked to review the process model and provide meaningful feedback. This is a common theme. But the stakeholders are asked to evaluate and make judgments on a process model that they have never seen before. This, in turn, leads to additional efforts to explain the model and to resolve misunderstandings. In some cases, domain experts reject process models because they are unable to read the model and conclude that their domain knowledge is not appropriately represented. Problems in communication about the process lead to a significant loss of time and money. However, it is essential that all stakeholders reach consensus about the current and the desired situation before the process becomes implemented in a software system. Given these pain points in contemporary process modeling practice, authors chose process elicitation to be the starting point in exploring how to improve the quality of communication between domain experts and process analysts. Research question: how to improve the quality of communication? Given the current situation, authors asked themselves what could be done to improve the communication between the domain experts, those that implicitly have the process knowledge, and the method experts, those that elicit the information and have knowledge about process modeling. The quality of communication is crucial to the success in any projects. Additionally, authors' research was driven by the following questions: how to create a shared understanding based on a shared representation? How to receive detailed feedback and detailed information about a process? How to enable people to reflect on their process and get new insights? How can we strengthen understanding? Iterating ideas. In November 2008, a group of researchers from the Center of Design Research, CDR, at Stanford University and Hasso-Plattner Institute, HPI, at University of Potsdam met for a first workshop. As part of the discussions and knowledge exchange, authors as researchers from the Business Process Technology Group told about aspects of process models for communication. During the discussions, the idea was born to explore more lively settings to let people experience the process rather than confronting them with a prepared model on paper. With this idea, authors have built the prototypes and the observations were made for improvement. Through constant iterations, authors developed a solution called as TBPM, Tangible Business Process Modeling. First iteration. The very same day the idea was born, researchers from CDR and HPI performed a first prototype. The goal was to explore the possibility of experiencing the process rather than discussing it. The group decided to do a role-playing exercise. The notion was that by playing it, they could come up with a general understanding of the process involving all partners. Authors chose a scenario based on the transactions surrounding a fictitious bicycle shop. This scenario assumed multiple stakeholders, customers, suppliers, fabricators, bank, simulating the process of ordering and buying a bicycle. When a customer ordered a bike, it had to be manufactured. When parts were missing, the bike shop had to order new material from the suppliers. Money was transferred via the bank. See the figure. Figure shows snapshots from the first prototype. To perform the role play, participants were provided with all possible material available at the D School in Potsdam. Lego and arbitrary material was available to explore the experience of a process as a role-playing game. Authors allowed about 1.5 hours to get the people into playing mode, play the game and talk about the findings. In the spirit of the practices of innovative design development, they did not establish explicit rules. Instead, they wanted to see what the situation would suggest to them as a way of moving forward. Observations and learnings. All participants enjoyed playing. Creativity spawned alliances between suppliers, variable interest rates from the bank and new bike shop offers. However, authors also observed some confusion about Lego pieces and what they represented. For example, one player assumed that a Lego piece was a bike part, another player a bicycle, and still another player assumed it was money. Negotiating meanings did consume some time. Painting or tagging the objects with a post-it makes it far easier to share a common understanding. Still, confusion about objects and their associated meanings were common during the game. The most confusing issue was concurrency. Playing the game with several stakeholders at the same time added complexity to following and understanding the actions on the table. As authors did not restrict the play, many different threads were active in parallel at a time. This made it hard to track the state of the interactions at the table. That also led to the effect that not one process instance was processed at a time, but many different instances were spawned. In other words, more than one bike order was in progress. Although this is a realistic setting, the team realized that the condensed nature of a role play was overcharging participants with impressions. Authors concluded that there was a huge potential in playing out the process rather than modeling it. The level of engagement and fun was fascinating. Yet, further refinements were obviously needed to steer the actions on the table and allow for more traceable interactions. Second iteration. During the research retreat of the Business Process Technology Group, authors decided to do another iteration of the game. The goal was to incorporate the learnings from the first prototype and explore ways to channel communication. A special focus was on the message exchange between participants. Participants of the first iteration reported that they had difficulties tracing the information exchange. Authors prepared wooden whiteboard plates, dry erase, to capture conversations. They were past equivalent to email threads with an evolving story. See the figure. Figure shows the snapshots from the second prototype. Experimenting with different material to channel the conversations. Authors prepared wooden whiteboard plates, dry erase, to capture conversations. They were past equivalent to email threads with an evolving story. Alternatively, they prepared message cards. They had the size of a post-it and framed each message to have a sender, receiver, header and body. Both approaches aimed to channel and capture the communication at the table. They formed 4 different groups. Each group had the size of 3 to 4 people. Authors restricted the roles to the bike shop, customer, supplier and bank in case of 4 players. They made all groups aware of the learnings from the first prototype and explained the alternatives to channel interactions at the table. Each group was free to choose their interaction channels. The groups had additional materials such as Lego, paper and scissors to help themselves. Also, they handed 2 of the groups a ball. It represented a mutually exclusive token that would only allow one person to act at a time. Authors allowed 1 hour to get the groups into playing mode and play the game. Afterwards, a moderated group discussion was held to let the groups share their findings and collect suggestions for further investigations. Observations and learnings. Again, the participants enjoyed playing the game. They used the preparation time extensively to identify with their role, like a person built a bike from paper to identify with his role as a bike shop owner. On the other hand, the creative potential also unfolded many exceptional cases of the bike shop scenario that made it more interesting for the players. In other words, players were making up new problems to keep the game from the boring, normal path. Authors concluded that the game would need objectives for the players that would motivate and therefore direct them. An important aspect of this iteration was capturing of information that is passed between participants. The real information was passed verbally, and the scripture on the plate served as a memory aid. That was okay for short-term memory recall, but already at the group discussion after the game a lot of information was not recallable. Similarly, the group that used the message cards reported that message cards were barely useful. The written text did not reflected the full information. A long description would also be counterintuitive to the dynamics of the game. Authors concluded that written messages are not feasible to capture the dynamics of the interactions at the table. The groups that used a ball in the game reported that this worked but revealed new problems. The concept of the ball was to sequentialize the actions on the table and therefore enable better tracing for the participants. While that worked as anticipated, sequential actions led to long idle times for other players. Thus, participants shifted their attention, and when it was their turn, they were not up to date with the state of the game. Due to the length of the game and the potential depth of discussions, authors concluded that they needed to find a way to allow participants to fade out their attention and still get back into the game. When collecting feedback, multiple participants independently reported that they would like to have a game master. That would allow them to test the limits instead of carefully following guidelines. While playing, they would rather like to think about the content than about the rules of the game. Third iteration. Weeks later, authors did a new iteration. The goal was to investigate how one could make the role-playing a more challenging game with an agenda. For this iteration, authors limited the information exchange to post-its. Authors changed the setting of the game to an online auctioning scenario. Competing for the lowest price was considered a reasonably goal for the players. They asked 5 HPI students and colleagues to act as stakeholders: online auctioneer, post office, bidder 1, bidder 2, and seller. Authors shortened and guided the preparation phase. All participants were asked to fill in a sheet. It should help them to develop empathy with their role. As an example, authors asked the participants about the motivation of their role. More importantly, they were asked to create the message post-its that they assumed to be needing later in the game. Every participant had a unique colored post-it set to codify the sender of a message. In addition, This iteration included a game master. It was on him to watch the actions of the game and ensure rule compliance. To capture the actions on the table, authors used a dictaphone. It sequentialized the actions on the table, just as the ball did in the last iteration. See the figure. Figure shows snapshots from the third prototype. Using prepared steps on post-its turned out to limit the scope of the game. In this iteration, more importantly, the dictaphone forced participants to take well-defined moves. Only an action spoken to the dictaphone was valid and conveniently captured the flow of the game for the researchers. Observations and learnings. The preparation phase was quite helpful for the players to develop empathy for the users. The prepared activities on post-its were of value as such that they allowed participants to think about their role in the process. Later in the game, people used almost every post-it and rarely created new ones. Only one person had to recreate most of his post-its, the post office role, because his assumptions proved wrong during the gameplay. The post-its created during the game's preparation stage were rather restrictive during the actual gaming session. Almost all participants were strongly motivated to fit these anticipated activities into the game. Authors concluded that the prepared post-its limited the thinking scope of the participants and changed the nature of the game from an explorative nature to a competitive nature. Unintentionally, the challenge became whether a participant could place all post-its later in the game. A new observation was that the stream of post-its captured quite well the events of interactions. It represented the state of the game which participants liked. They even asked for more details, like the time until the end of an auction to be represented on the table. Post-its were used now to capture a mix of information types such as messages, actions, and money. This stream of post-its was an even better documentation of the process than the messages spoken to the dictaphone. Still, it was a stream of post-its and one had to read them all to get a picture of the process. Authors concluded that participants are able to map their process knowledge, yet we needed a better framework to guide them. In interviews after the prototype, some participants reported that the setting was rather boring than fun. Authors concluded that the restrictions applied by us in this iteration were not compensated by the gameplay. Fourth iteration. From the last iterations, author learned that group sessions with a gameplay environment need guidance and motivational factors. Authors also learned that people wanted a shared representation of the process knowledge. In this iteration, authors took a step back to focus on the type of representation used to share the process knowledge. In order to simplify the task, authors looked at interviews with single process stakeholders. Authors' goal was to find out whether the individuals can map their process knowledge in a structured manner. Instead of letting everybody interact, one knowledge carrier should be enabled to map her process. See the figure. Figure shows the fourth iteration. Exploring acrylic tiles to let individuals map out their process steps from previous iterations, authors knew that post-its and a certain framing like the message cards would probably help. When Jonathan Edelman from CDR visited HPI, he brought a set of white acrylic tiles based on systems modeling iconography. The white acrylic afforded writing with a dry erase marker right on the piece, making the content easily changeable. The different shaping of the pieces imposed a certain semantics, meaning that only certain information would be held on certain shapes. Furthermore, the pieces were made large enough to require gross motor coordination in order to manipulate them with the hands. Authors decided to test these tiles in interview situations. As participants for the interviews, authors asked administrative assistants at HPI, Potsdam. Authors conducted 3 interviews in which they asked to describe the process of booking travel and accommodation for faculty members visiting a conference. The researcher conducting the interview tried to map the process together with the interviewee to the acrylic shapes. Observations and learnings. Authors found that the acrylic shapes worked well as a shared object that the interviewee and interviewer could talk about. Stepwise unfolding the process allowed the interviewee to follow the act of knowledge capturing and contribute her knowledge. In 2 out of 3 cases, the interviewee took the dry erase pen and started correcting or mapping information. Authors concluded that this is an easily accessible tool for everybody to get engaged with. The elements used did not reflect the process modeling iconography, although they looked similar. In some situations, this was a limitation, as we could not frame all the knowledge to the concepts given in process modeling languages. Authors concluded that, given a full modeling language in plastic, domain experts could possibly map and frame the processes themselves. 5th iteration. Equipped with learnings from the last iteration, authors designed a new set based on the same material. Authors decided on the size, the shapes needed, and the amount of elements per shape. Care was taken to design the pieces so they were big enough to write on them with dry erase markers and comfortably hold them in the hand. A complete set was made of 120 pieces. Yet, this set had only 4 basic shapes: activities, events, data objects, and gateways. They reflect main artifacts of the business process modeling notation, BPMN, the process modeling language of choice. Through markup of the shapes, all language elements can be derived. See the figure. Figure shows 5th iteration. First run using an acrylic set that represents BPMN iconography. Authors called this iteration the TBPM set, Tangible Business Process Modeling. The iconography moved nearer to the actual process modeling language and the resulting model. The table used for interviews would permit drawing on it. Thus, authors could capture orders of activities, associations, annotations, and responsibilities by drawing on the table itself. Again, authors interviewed office assistants for standard processes such as travel planning and conference organization. Authors used structured interviews and the TBPM toolkit. They wanted to see whether the domain experts would accept the tool and how they would apply it. Observations and learnings. People were reluctant to use the TBPM toolkit at first. Throughout the interviews, authors found it effective if the interviewer listens and models the first steps of the process while explaining the concepts behind the objects. After the interviewer has mapped the first steps, the interviewees started writing on the blocks themselves. The first steps also set the level of granularity for all other discussions. Authors concluded that an introduction to process modeling is quite easy if done by a working example. Authors did not explicitly introduce the concept of control flow or gateways in BPMN. Intuitively, interviewees accepted a logical order if steps were laid out from left to right. Parallelism and alternatives were both captured by putting activities one over another. Only in processes where both concepts occurred together, gateways were introduced. In general, authors introduced as few process modeling concepts as possible to reduce distraction from the problem itself. Authors concluded that these people are able to frame their knowledge and create process models themselves. Experiences with the TBPM toolkit. As of now, authors have done more than 50 interview situations using the set from the 5th iteration. Authors can say from their experience, it works. The semantics associated with the different shapes focus the discussion at the table and push the participants to frame their output to fit into the concepts of process modeling. Authors could even transport the idea to group modeling sessions as initially intended. The analogy to children's blocks dramatically lowers the barrier for non-process modelers to use the toolkit, participate in process modeling, and contribute their knowledge. Everybody at the table can easily create, delete, arrange and rearrange objects. The immediate mapping of the implicit knowledge allows people to reflect the process with their knowledge. Subsequent discussions are more precise as people can point at the part of the process that they are talking about. The process mapped down at the table represents the knowledge gathered. That is not to say that methodological guidance is obsolete. Authors are still working out the details of a proper introduction and moderation techniques for both interviews and group modeling sessions. As such, authors have conducted a series of case studies. As an example, authors compared TBPM interviews with traditional structured interviews and interviews supported by post-its. They found that TBPM interviews take much more time because the interviewees have to frame their knowledge. As a benefit, the result is already a process model. That relieves the interviewer from interpreting the interview and creating his own process. Using post-its in interviews did not provide such a process framing. Authors have published papers on TBPM and presented it to professionals and received positive feedback and further ideas for refinement of the method and toolkit. Research methodology. At a first glance, this project is no research, is it? Why is this science and not just another invention? When authors started investigating how to achieve more user involvement, authors did not know how the solution would look like. Authors did not even have a clear research question as outlined now. The ideas that popped up were investigated by immediate prototyping. A prototype does not have to represent the overall situation but the particular aspect to be investigated. Thus, it was fair to start with a wild game to investigate the fun factors that made people be engaged. The early prototyping approach allowed many iterations with low effort. Indeed, this started as a side project and only little time is available throughout the first year to investigate the issue. See the figure. Figure shows 4 steps in this research. Authors call this first step the initial learning cycle. The theme is to test out ideas as early as possible to get feedback. Documenting iterations and reflecting on the lessons learned is an important aspect of the learning cycle. Observations might be easily captured, but learnings need time to settle. Over time, memories fade, and good documentation of the original impressions might yield new insights even weeks and months later. What authors ended up with is a working solution. Learning is still ongoing, and refinements to the working solution are very likely. Refining the hypotheses and setting up a laboratory experiment are the next steps towards a scientific investigation of TBPM. The goal of a rigorous scientific investigation is not to show that TBPM works. Authors hypothesize some reasons and planned to test them. They seek to understand better how different aspects, such as tangibility, accessibility, shared model ownership, and moderation work together. From that investigation, authors can draw more general conclusions. Authors call these transportable findings, which are applicable to more domains and different problems.